The last remaining territory on the planet that could have such a designation is Antarctica.
So a new discovery in Antarctica. Researchers find new life under an ice shelf, and the discovery was an accident.
Have you ever wondered what secrets lie hidden beneath the icy expanse of Antarctica?
Scientists are also increasingly concerned about what's happening to the sea ice around Antarctica.
Russia's latest discoveries there are sending shockwaves through the scientific community, unveiling mysteries that are both fascinating and a little bit terrifying.
Researchers have discovered a crater 1.5 kilometers beneath the Antarctica ice crust, 482 kilometers in diameter.
Let's embark on a chilly journey to uncover these icy enigmas. Number 1. The mysterious microbes of Lake Vosto. In the heart of Antarctica, under miles of ice, lies Lake Vosto, a subglacial lake as mysterious as it is intriguing. Discovered beneath the Russian Vostok station, this hidden gem has remained isolated from the world for over 15 million years. Can you imagine a lake untouched by sunlight for that long? It's like finding a time capsule from Earth's distant past, but instead of old letters, it's filled with ancient microbes. The lake, stretching over 14,000 square kilometers, is an icy fortress, guarding its secrets beneath nearly 4 kilometers of solid ice. Now, you might think, how could anything possibly live there? Well, that's where it gets interesting. The extreme conditions of Lake Vosto have become a home for unique microorganisms, surviving in an environment devoid of light and with intense pressure. Scientists call these hardy organisms extremophiles because, well, they love extreme conditions. Kind of like people who enjoy pineapple on pizza, but way cooler. The discovery of these microbes opens a Pandora's box of questions. How do these organisms survive? What can they tell us about life on other planets? You see, finding life in such extreme conditions on Earth hints that life might just be possible on other icy worlds in our solar system, like Jupiter's moon Europa. Imagine that, cousins of Lake Vostok's microbes living on another planet. But there's a catch. To study these microbes, scientists need to drill through the ice, and that's no easy feat. There's a real concern about contaminating this pristine environment. Think about it. Introducing surface microbes into Lake Vosto would be like bringing a bull into a china shop, only with bacteria and a unique ecosystem. And once we alter it, there's no going back.
Again, it's thousands of feet down. It's 4,500 to 5,000 feet down, yet there was life.
The microorganisms of Lake Vosto are not just surviving. They are thriving in conditions that would make most earthly life forms throw in the towel. They've adapted to the cold, the pressure, and the lack of sunlight in ways that baffle scientists. Some of these adaptations include unique molecular and physiological changes. It's like they have their own little set of superpowers, specially designed for the cold. Interestingly, not only do these organisms endure the cold, but they also face high salt concentrations. Ever put salt on ice during winter? It melts, right? But in Lake Vosto, the salts don't just melt the ice. They create a unique habitat for these organisms. It's a bit like living in a salty ice slushy, not exactly a human's idea of a cozy home. In one of the more eyebrow-raising discoveries, scientists detected a thermophilic bacterium deep in the lake, similar to those found in hot springs like those in Yellowstone. This finding could point to geothermal activity beneath the lake, hinting that it's not just cold and dark down there, but there might also be a bit of a subglacial sauna happening. Now, let's not forget the moment in 2013 when Russian scientists found organisms in Lake Vosto that seemed different from any known life form on Earth. That's right, not just different, but altogether unique. This finding sent ripples through the scientific world, sparking debates and discussions about the diversity of life on our planet.
One of the things I find most striking is the presence of Antarctica on ancient maps, because we didn't discover it until 1820.
The study of these organisms isn't just about satisfying our curiosity, it has practical implications too. Understanding how life can exist in such extreme conditions can help us in fields like biotechnology and medicine. Who knows, the microbes of Lake Vostok might one day lead to breakthroughs in developing new drugs or cleaning up environmental pollutants. It's like finding a tiny microbial gold mine. But the story of Lake Vostok is more than just a tale of scientific discovery. It's a reminder of how little we know about our own planet. It challenges us to think about the resilience of life and the vast, unexplored mysteries lying beneath our feet, or in this case, beneath layers of ice. It also poses ethical dilemmas about exploration and conservation. How far should we go in uncovering the secrets of such a unique environment? As we continue to explore and understand Lake Vostok, we tread a fine line between discovery and preservation. Each new finding is a piece of a larger puzzle, revealing the complexities of life on Earth and perhaps beyond. The microbes of Lake Vostok are not just survivors of extreme conditions. They are storytellers, narrating a tale of resilience, adaptation, and the unending quest for knowledge in one of the most remote and untouched places on Earth. So next time you're sipping a cold drink, spare a thought for the tiny, tough inhabitants of Lake Vostok living in their dark, icy world. They might just be the most resilient neighbors we have on this planet, and they're teaching us more about life's possibilities than we ever imagined. And who knows, maybe one day we'll discover even more surprising secrets hidden in the depths of this. Number 2. Hidden mountains and subglacial landscapes. Imagine, if you will, a landscape more majestic than the European Alps, a sprawling expanse of mountains and valleys, rivers and lakes. Now, picture this stunning terrain hidden completely under ice, unseen by human eyes for millennia. This is not the setting of a fantasy novel. This is the reality of the subglacial landscapes of Antarctica, a world beneath our world. Tucked away under the vast ice sheets of East Antarctica, these hidden mountains are a marvel. They're more than just bumps under the ice. They are towering peaks and deep valleys akin to the Alps in their grandeur. But unlike the Alps, with their picturesque villages and ski resorts, these mountains are entombed in ice, preserved in a chilly time capsule. The discovery of these subglacial mountains reshapes our understanding of Earth's least explored continent. It's like finding a secret room in your house that you never knew existed. These mountains, known as the Gambut Mountains, were first detected in the late 1950s. But it wasn't until recent years, with advanced technology like ice-penetrating radar, that their true scale and beauty came into focus. Picture this, peaks rising more than 8,000 feet, comparable to some of the tallest alpine summits. They're buried under a mile or more of ice. It's hard to fathom, isn't it? An alpine wonderland hidden away in a cold, dark place. The images we have of these mountains come not from photographs, but from radar and satellite data, painting a picture of a rugged landscape that has never felt the warmth of the sun for millions of years. So, why does this matter, you might ask? Well, these subglacial landscapes hold clues to our planet's past and future. They're like a giant history book waiting to be read. These mountains and valleys influence how ice flows in Antarctica, and understanding this can help us predict future changes in ice sheets and global sea levels. It's a bit like piecing together a giant frozen jigsaw puzzle that can tell us where we might be heading in terms of climate change. The discovery of liquid water in the form of lakes and rivers under the ice adds another layer of intrigue. These hidden bodies of water are not frozen solid, but exist as liquid due to the pressure of the ice above and the geothermal heat from below. It's like finding an oasis in the desert, but this one is under a sea of ice. These subglacial lakes are of great interest to scientists because they might host unique forms of life, adapted to conditions that we once thought impossible for life to exist. But there's more. The formation of these mountains is a geological puzzle. How did such massive features form far away from tectonic plate boundaries? The answer lies in the ancient movements of Earth's crust. These mountains are the remnants of a time when Antarctica was part of a larger supercontinent. They tell a story of continental drift and the dynamic nature of our planet's surface. The Gambut Mountains challenge our understanding of mountain formation. Typically, we think of mountains forming due to tectonic activity. But these mountains seem to defy this logic, raising questions about other possible processes that could shape our planet's landscape. It's like discovering a new recipe in the cookbook of Earth's geology. For explorers and scientists, these subglacial landscapes are the final frontier on Earth, a place as mysterious and unexplored as the dark side of the moon or the deepest ocean trenches. They remind us that our planet still has secrets, waiting to be uncovered. The significance of these hidden mountains and valleys extends beyond scientific curiosity. They are a testament to the wonders of our planet, a reminder of the incredible processes that have shaped and continue to shape our world. In a time when our planet faces many challenges, these discoveries are a beacon of wonder, a reminder of the beauty and mystery that still exist in the farthest corners of our world. Number 3. Tunguska event and meteorite discoveries. The Tunguska event, a colossal explosion that occurred in a remote region of Siberia on June 30, 1908, has puzzled scientists and enthusiasts for over a century. This monumental blast flattened an estimated 80 million trees over an area of 2,000 square kilometers and was felt hundreds of kilometers away. For years, the cause of this event remained a mystery, sparking theories ranging from a comet or asteroid impact to more outlandish explanations involving extraterrestrial activity. However, a surprising twist in this tale links the Tunguska event to discoveries thousands of miles away in the icy expanse of Antarctica. Fast forward to the modern era, where scientists, armed with sophisticated technology, have unearthed clues in the most unlikely of places: Antarctica. The discovery of meteorites in this frozen wasteland has opened new doors in understanding the Tunguska event. It's like finding a missing puzzle piece in your attic that solves a decades-old family mystery. But why Antarctica, you might ask? Well, Antarctica is a meteorite hunter's paradise. Its white, icy expanses make these dark celestial rocks easier to spot, and its dry, cold conditions help preserve them. Think of it as nature's own freezer, keeping these space treasures in mint condition. Researchers have found that some of these meteorites bear striking similarities to the expected remnants of the Tunguska event. For instance, specific isotopic compositions and the presence of certain minerals that form under high-pressure conditions point towards a cosmic origin, similar to what's theorized for the Tunguska explosion. It's like finding traces of flour and sugar on your kitchen counter and deducing someone's been baking cookies. One of the most intriguing aspects of these meteorites is their potential to offer insights into the type of object that caused the Tunguska event. Was it a comet, an asteroid, or something else? By studying the composition and structure of these meteorites, scientists can gather clues about the Tunguska object. It's a bit like forensic scientists piecing together evidence at a crime scene, only the scene is spread across continents, and the crime is a natural, cosmic event. The significance of connecting meteorites in Antarctica to the Tunguska event extends beyond solving a historical mystery. It underscores the interconnectedness of our planet and the universe. An event in remote Siberia can have ties to rocks found on the opposite pole of the Earth. It's a humbling reminder of how global and indeed interplanetary our existence is. Moreover, these discoveries in Antarctica have broader implications in the field of planetary science. They contribute to our understanding of meteorites as carriers of cosmic information. These ancient rocks, hurtling through space for eons before crashing onto our planet, are time capsules containing clues about the early solar system. They hold answers to fundamental questions about the origins of the solar system and, by extension, our place in the universe. But let's not forget the impact implications. Studying these meteorites helps us understand the potential threats posed by near-Earth objects. The Tunguska event, though not fatal to humans, was a stark demonstration of the power of cosmic impacts. By unraveling its mysteries, we're better equipped to predict and hopefully mitigate future threats. It's like studying past earthquakes to build safer buildings. The pursuit of knowledge about the Tunguska event and its Antarctic connections also embodies the human spirit of exploration and curiosity. It highlights our innate desire to explore the unknown, to venture into uncharted territories, whether they be the icy plains of Antarctica or the depths of space. Each meteorite recovered, each analysis completed, adds a piece to the grand puzzle of our universe. Number 4. The enigma of blood falls. In the stark, icy landscape of Antarctica, a phenomenon both bizarre and captivating emerges: blood falls. This natural wonder, appearing as a crimson cascade flowing from the Taylor Glacier, paints a stark contrast against the white and blue backdrop of its icy surroundings. Its discovery, like something out of a Gothic novel, has intrigued scientists and adventurers alike for over a century. The story of blood falls begins in 1911, when Australian geologist Griffith Taylor first stumbled upon this eerie site during the Terra Nova expedition. Imagine the surprise and bewilderment of coming across a blood-red waterfall in one of the most remote places on Earth. It was as if the ice itself was bleeding. For decades, the source of this red color was a subject of speculation and mystery. Was it red algae, iron oxide, or something more sinister? The answer, as it turns out, is both fascinating and a testament to the resilience of life in extreme environments. Blood falls is not the result of a gruesome event, but a natural time capsule from a bygone era. The red hue comes from iron oxide, or rust, essentially. But where does this iron come from? The answer lies beneath the glacier, deep beneath Taylor. Glacier lies an ancient, subglacial lake. Over 2 million years old, this lake has been sealed off from the rest of the world, its waters trapped under a thick layer of ice. This isolation has created a unique ecosystem. The lake is rich in iron, which was once part of the bedrock. Microorganisms in the lake use this iron along with sulfate for energy in a process similar to how we use oxygen. When iron-rich water from this lake leaks out to the surface, it comes in contact with air, oxidizing the iron and giving the waterfall its characteristic red color. The discovery of blood falls has revolutionized our understanding of life in extreme conditions. The microorganisms living in the lake beneath the glacier are extremophiles, capable of surviving in conditions that were previously thought to be too harsh for life. They thrive in an environment that is not only cold and dark, but also high in salinity and completely devoid of oxygen. It's a stark reminder of life's incredible adaptability and raises exciting possibilities about life existing in similar extreme environments elsewhere in our solar system, like on Mars or Jupiter's moon Europa. Blood falls also provides valuable insights into Earth's past climate. The trapped lake is a relic of a time when the climate in Antarctica was warmer and the sea levels were higher. As such, it offers a unique opportunity for scientists to study conditions similar to those that existed on Earth millions of years ago. It's like having a time machine that allows us to peek into the ancient past, offering clues about how our planet's climate has changed and how it might change in the future. The study of blood falls and its subglacial ecosystem also challenges our understanding of life's limits. The extremophiles found here don't just survive, they flourish in an environment devoid of sunlight, relying on chemicals like sulfur and iron for their energy. This discovery broadens our perception of the conditions necessary for life and has implications for our search for extraterrestrial life. If life can thrive in the harsh conditions of blood falls, what other extreme environments might it exist in? Moreover, blood falls is a symbol of the mysteries that still lie hidden in the remote corners of our planet. It reminds us that Earth is still full of unexplored and poorly understood places, each with the potential to change our understanding of the world. For scientists, it represents an exciting and challenging frontier for research, offering new opportunities to explore the limits of life and the history of our planet. Number 5. Unraveling the secrets of Gambut Mountains. Deep beneath the East Antarctic ice sheet, hidden from view, lies a mountain range that rivals the European Alps in grandeur, the Gambut Mountains. Discovered in the late 1950s during the International Geophysical Year, these subglacial mountains have captivated scientists and sparked curiosity worldwide. Standing up to 3,400 meters tall, these mountains, buried under kilometers of ice, present a fascinating geological puzzle. How did such a massive mountain range form in one of the most remote and unexpected places on Earth? The mystery of the Gambut Mountains is akin to finding a lost world under the sea or a hidden city in the jungle. Their existence challenges our understanding of mountain formation and tectonic processes. Typically, mountains form at tectonic plate boundaries, where plates collide, separate, or slide past each other. But the Gambut Mountains are located far from any plate boundaries, nestled in the heart of the Antarctic plate. This enigmatic location raises a fundamental question. How were these mountains formed? To understand the formation of the Gambut Mountains, we must travel back in time, hundreds of millions of years, to a period when Antarctica was part of the supercontinent Gondwana. During this time, tectonic forces were at play, shaping the land that would become Antarctica. The prevailing theory suggests that the mountains formed during a period of intense tectonic activity as parts of the supercontinent were pulled apart and pushed together. This tumultuous period resulted in the folding and faulting of the Earth's crust, giving rise to the Gambut Mountains. But the story doesn't end there. After their formation, the mountains underwent a series of dramatic transformations. They were likely eroded down to their roots, only to be rejuvenated millions of years later through further tectonic uplift. This complex history of formation, erosion, and rejuvenation makes the Gambut Mountains a unique geological wonder. The discovery of the Gambut Mountains was not just a stroke of luck. It was the result of meticulous scientific exploration using technologies such as ice-penetrating radar, seismic surveys, and magnetic and gravity measurements. These technologies allowed scientists to peer through the thick ice and glimpse the hidden mountains below. The data gathered from these explorations paints a picture of a rugged landscape, with deep valleys and towering peaks, all encased in a frozen tomb. The significance of the Gambut Mountains extends beyond their mysterious origins. These mountains are also key to understanding the history of the Antarctic ice sheet. The topography of the mountains influences how ice flows and accumulates, playing a crucial role in the formation and stability of the ice sheet. By studying the Gambut Mountains, scientists can gain insights into the past dynamics of the ice sheet, which is essential for predicting how it may respond to a warming climate. Furthermore, the Gambut Mountains are a testament to the dynamic nature of our planet. They remind us that the Earth's surface is constantly changing, shaped by forces that operate over timescales far beyond human comprehension. In a world where we are accustomed to rapid change, the slow, relentless forces that shaped the Gambut Mountains offer a humbling perspective on the natural world. Number 6. Exploring the extremes, the fascinating world of Vostok Station. In the vast, icy expanse of Antarctica, a realm of extreme cold and isolation, lies an array of secrets waiting to be unraveled. Among these is the remarkable phenomenon of extreme radiation levels and environmental conditions at Russia's Vostok Station, located near the South Pole. This chapter delves into the intriguing world of Vostok Station, exploring its extraordinary environmental conditions, the challenges they present, and the scientific significance of this remote outpost in one of Earth's harshest environments. Vostok Station, established by the Soviet Union in 1957, sits atop Lake Vostok, buried under the Antarctic ice. It is renowned for recording the lowest natural temperature on Earth, a bone-chilling -89.2 degrees Celsius, on July 21, 1983. But extreme cold is not the only challenge here. Vostok Station is also one of the sunniest places on the planet, despite being shrouded in darkness for long periods during the Antarctic winter. This paradoxical combination of intense sunlight and extreme cold creates a unique environment for scientific research. The station's high altitude and the thinness of the ozone layer above Antarctica result in unusually high levels of ultraviolet radiation. This poses significant challenges for both the environment and the researchers working at the station. The intense UV radiation increases the risk of skin cancer and can cause damage to the eyes. For the environment, it can affect the delicate balance of microbial life, adapted to the extreme conditions of the region. But why is this important? Studying the effects of high UV radiation in such an extreme environment can provide valuable insights into the potential impacts of ozone depletion in other parts of the world. It's a natural laboratory for understanding how life adapts to harsh conditions and the implications of human-induced changes in our atmosphere. The isolation of Vostok Station adds another layer of complexity to its environment. Located far from any ocean and accessible only by icebreaker ships or aircraft during the brief Antarctic summer, the station is one of the most remote inhabited places on Earth. This isolation has significant implications for both the logistics of running the station and the psychological well-being of its inhabitants. The station's crew must be prepared to endure months of isolation, with limited resources and no possibility of quick evacuation in case of emergencies. Despite these challenges, Vostok Station is a crucial hub for scientific research. The ice core samples collected here have provided invaluable data on Earth's climate history, going back hundreds of thousands of years. By analyzing these ice cores, scientists can reconstruct past atmospheric compositions, temperatures, and even find traces of volcanic eruptions. This information is vital for understanding how our planet's climate has changed over time and for making predictions about future climate trends. The discovery of Lake Vostok, the subglacial lake beneath the station, has opened new frontiers in the study of extremophiles, organisms that thrive in extreme conditions. The lake's waters have been isolated from the surface for millions of years, potentially hosting unique forms of microbial life. Studying these organisms can provide insights into the limits of life on Earth and guide the search for life on other planets. Moreover, the research conducted at Vostok Station contributes to our understanding of Antarctic glaciology. The station's location on the ice sheet provides an ideal setting for studying the dynamics of ice flow and its impact on global sea levels. In a world where climate change is causing rapid ice melt in polar regions, understanding these processes is more important than ever. Vostok Station is also a testament to human resilience and the spirit of exploration. It represents our willingness to push the boundaries of our knowledge and to venture into the unknown, despite the risks and challenges. The scientists and support staff who work at this remote outpost are part of a long tradition of polar explorers, contributing to our understanding of one of the planet's last frontiers.